Hey, welcome everyone. Welcome to Cross the Streams, creating data pipelines with Pulsar and Flink SQL. So here's what I'll be talking about today. Firstly, who am I and why am I talking about this? Secondly, I will do a brief introduction to Flink SQL with a focus on the components that are leveraged best by Pulsar. This is intended to be a quick and easy start for anyone who's either new to combining these two or who is not familiar with Flink SQL. So I'm trying to make this as beginner-friendly as possible, a bit more of an intro, and then I'm going to have a whole bunch of steps at the end for more and more complicated places to go once you're ready for it. So next I'll do a Flink SQL demo. This will be fast and simple, hopefully fun. And then theoretically, you should be able to follow along with me as you go. So if you want to, that's definitely an option. And then lastly, I will be connecting the dots, how Flink and Pulsar interact with a Flink SQL and Pulsar demo. So who am I? For those of you who don't know me, my name is Kato Schur, and I first got started with stream processing in 2017 when I was a software engineer at a large data analytics company. My team at that company built our first ever stream processing data pipeline using Apache Flink. And I started giving talks at that point about our experiencing, diving into the deep end of the stream, as it were. And that's where I got hooked on the open source community, specifically around Flink, but also around stream processing. So big shout out to all the open source stream processors out there. This is also where I learned to finally like squirrels. So you'll see a cute little pink squirrel mascot. That's the Flink mascot. And if you do like the little pink squirrel, or if you like stickers, or if you hate squirrels but like stickers, come find me afterward. I've got a lot of Flink stickers and stickers of my dog if you don't like squirrels. And I work at Prereqs, formerly known as Data Artisans. This is the company that built and maintains Apache Flink. They also have an integrated platform that organizes and enables developers and orgs to get immediate insight into their data and helps kind of streamline deployments and operations. I am their developer advocate for the US region. And I work remote for them, so I live in Portland, Oregon, which is how I'm able to kind of represent the US community there. And in my free time, I love woodworking, running, dance, and appreciating terrible puns. So I can't always think of them on the spot. If you've got a good one, definitely come find me later. Sorry, not sorry, there's a couple puns in here. I think there's about 3. So if you're starting to get a little sleepy after lunch, fun game for you. I guess winner gets Flink stickers. But yeah, see if you can find them all. So I did choose the Portland carpet logo to represent my hometown. Anyone who's not familiar, Portland had a hideously ugly carpet in the 80s and 90s that people like myself got kind of unreasonably attached to. So of course I'm going to use that to represent Portland. And now that's something you've already learned that's new. Also, last time I gave this intro, the AV cut out at this point, and someone in the audience shouted that it was because I insulted ugly carpets. So this carpet looks pretty nice, so I think we're safe. So, but if it cuts out, I'm going to blame that. All right, so getting more serious, only a little more serious, I promise. A little intro into what even is Flink SQL. So first I'll go into what the challenge that Flink SQL and Flink specifically were built to solve. But before that, is anyone in here not familiar with stream processing? Okay, sweet, good. I can skip that part. How many of you are familiar with Flink? All right, sweet, excellent. In that case, so first I'll go into, as I said, the challenge that it was built to solve. And so stream processing has a few challenges. Some are more obvious than others. And at the most basic level, you have unbounded streams of data. It just doesn't stop, or at least it shouldn't. If it does, you've got bigger problems. And in batch processing, you can just wait and process data. You can pause it if there's an issue, just keep things paused, and you're unlikely to have back pressure, data piling up, et cetera. And additionally, most of the benefits of stream processing are that it can handle just mass amounts of data being pushed through really quickly at just lightning speed. And you want to take advantage of those benefits because, why not? That's like why most people adopt stream processing in the first place. So the whole reason you'd want to use it kind of makes it inherently complicated. You also might be ingesting from multiple sources, maybe joining streams. These streams might be coming in different formats. You have this potential for just such a much more complex system, which is a good thing, but it means that it's more complex. And this often shows up with things like storage issues, data loss, duplication. This morning, we were hearing about exactly once guarantees and things like that. That's like my favorite streaming feature. So you want to make sure that you have something to compensate for that, and especially things like failure recovery. So if you're familiar with Flink, you can tune out for the next 2.5 slides. I will let you know when you can wake back up from your post-lunch nap after that. I will be trying to present it in the context that fits within stream processing and the Pulsar world. So although Flink now has unified batch and streaming processes, it is foremost known as a stateful stream processing engine. The rough translation of Flink means nimble in German, so that's going to highlight the flexibility and speed of the framework. And that's why we have the cute squirrel logo. So it is a particularly flexible and complex framework that was built to solve a lot of these software problems, particularly in the areas of real-time and big data processing. However, it was also built to address a lot of the common issues that come with stream processing, namely being able to provide features like high availability, various safeguards, and those exactly once guarantees. So all of this while maintaining high performance, low latency, and scalability for each of these components. It's also highly customizable, and it can be used for a wide variety of specialized cases. So most common use cases are data pipelines, but this is especially used for fraud and anomaly detection, where you want to have as precise data as possible while also being as near real time as possible. And things that often require a lot of complex transformations and doing those transformations quickly. So there's so much more in there. There's 10 more slides I could go on, but I want to make sure we got time for the demos. So in the interest of time, I want to bring it back to the main building blocks. So as a user, Flink gives you these different APIs to choose from that trade off ease of use and expressiveness. This is kind of like what we saw in the keynote this morning with, I love the diagram of the big circles and Pulsar SQL in the middle with the Pulsar client at the end there. So this is kind of the same idea, but the Flink version. So we have our APIs like SQL that we're going to be talking about, as well as PyFlink, the table API, that are more like your relational way of dealing with thinking about data. And these allow you to express problems in a really concise way and do all the operational heavy lifting for you. And as you progress down, using the APIs starts to get more complex, but you get more control over the programs that you're building and how they're executed. So in summary, we didn't get a chance to go really in depth into these, but this is essentially what you can kind of expect from most of the benefits that you'd be getting with Flink. So in summary, stream processing is extremely beneficial and really kind of essential for dealing with large amounts of data that you need to be able to access in as near real time as possible, among other use cases. Stream processing is inherently challenging and complicated. It is just hard, especially when you want to use more data and to do more complex things to that data. Flink was built both for high performance with the things that you want to have stream processing do for you, and it was built to address and mitigate a lot of the issues that are inherent with stream processing. Cool, that's awesome. But it can also mean it's a bit of a challenge to use. So the main benefits of Flink SQL are that you get access to all the benefits that we just saw on that slide, which is particularly useful for unified batch and streaming for distributed systems. Users can also focus on business logic and not on all the implementation details. This, along with the fact that it's just SQL, means that you don't have to be a deep dive Java or Scala expert. You don't have to worry about switching all your code over, making this just a really nice lightweight thing, giving developers more autonomy to be able to just jump right in. It really just abstracts that complexity. So moving on to Flink SQL. So I've taken a complex issue and I've tried to make the simplest solution possible. And I've done this the hard way enough times that I'm really passionate about trying to make this easy and hopefully fun and even accessible to non-developers. So I've made a demo that everyone should be able to follow along with if you want. Feel free to take screenshots. Or if you're just really stoked about it, it really only takes a couple minutes. You could do it anywhere. I am not actually advocating for you to take your laptop out in the bathroom, but this picture from the Free Guy movie was just too perfect. But hey, no one would even know you're creating data pipelines. I'm not gonna tell anyone. So with that, now for the fun part, at least I think this part's fun. So what is different about running SQL on a streaming engine? So in your regular database, just using regular SQL, not streaming SQL at all, where you execute your query at a certain point in time, the engine will take a snapshot of the table at the time the query was run, then computes the results based on that static snapshot, and then the query terminates. So this is all probably something we're kind of familiar with if we've looked a bit under the hood at SQL before. In streaming SQL, the query is continuous, just like streaming. So you first deploy your query, and then whenever data is added to the table, the changes are continuously ingested and results are continuously updated. The query keeps running and never finishes until you actually cancel the job. So quite a bit different under the hood. Keeping with our theme of simplicity here, it is just so much more simple. So this is an example of sessionizing a click stream and count on the number of clicks per session in regular Flink on the left here. Yeah, it's the left, all right. Using the data stream API versus using Flink SQL on the right here. So with Flink's other APIs, queries are still dependent on a table program written either in Java or Scala. And those often have dependencies like on a build tool for submitting your clusters, whereas the Flink SQL client, all writing, debugging, any sort of table programs to a Flink cluster is just done. So plus you get all your visualizations in the command line. So again, keeping this simple enough that you can follow along, the prereqs are super simple. I know it says Java on there, and I promise I am not gonna make you write new Java. Just to get that out there, I'm not gonna make you do that right now. But you do need to have Java 8 or 11 installed on your machine because there's dependencies on that on the Java heap in the background. So then you just download the current stable snapshot that's just in the Flink docs, and then you untar it. And that is literally it. So super simple. And then all you need to do is start a cluster. And at this point, you'll be able to open up the Flink UI that just comes out of the box of Flink. So just in localhost here. You'll see everything come up there right away. As I refresh that, there we go. And then you just, after you bask in the glory of it just coming up immediately, you then just start up the SQL client. So I'll leave that up there for a second. I think I did some typos in there the first time I wrote it. There we go. SQL client, and you just start that up. You can also use embedded mode when you start that up. So you are not gonna miss that you are in the SQL client. You are gonna see this gigantic squirrel. If you do not see a gigantic squirrel, then you've done something wrong. So just make sure that you see this guy here. And as a side note, just to leave this up here so we can all bask in the glory of the squirrel, quick side note is that the client supports 3 modes for maintaining and visualizing results. So I could have started this up differently depending on what format I wanted to use. We've got table mode, which materializes results in memory and visualizes them in like a regular paginated representation. Changelog mode, which does not materialize results, but instead it visualizes the actual stream, and that's produced by that continuous query, consisting of insertions and deletions. We have Tableau mode, which is more like the traditional way, and then as a side note, the changelog mode, in order to stay really responsive, since the results are stored on the Java heap in this sense, the changelog mode will only show the latest 1,000 messages. I like to say that because people are often like, oh my God, where'd my stuff go? So I like to say, you can change that, you can customize it, but that's just the default. So this part is super basic, but I always like to check the hello world built-in function because it's another really quick way to tell if something's wrong. I see a lot of people just skip this, and then the 2 most common issues that this tells you if you have are like the 2 simplest ones that I also see people like go off and do really complicated stuff, and it's like, no, you probably just have either your cluster and client on 2 different versions, or you're using your default ports up somewhere. So this is a quick way just to know that you don't need to do anything complicated. You just probably have one of those 2 problems. The client and cluster thing, if you're starting completely from scratch, is not gonna be an issue. That's more just if you have like an old version of Flink sitting around. So this first demo, I've started with the absolute most simple, so we're just gonna do a CSV file. I picked something that I was already using in my personal life. So in early 2020, a bunch of friends and I made a bunch of like fake journal, fake diary titles of our experiences in quarantine, and it became kind of this like humorous, but still hopefully like inclusive and relatable way to kind of sum up some of our feelings that year. But people got so into it that I suddenly had like hundreds of submissions over Slack messages and text messages and emails from relatives. Like it blew up. So I wanted to create a pipeline where people could just shove them all in there, and I could quickly sort everything and have filters for things like, if it had already been created into something on a website. Also, if it was work safe, that was an important filter to add because people wanted to share these at work. So then you enter that and you immediately just get this nice and easy table display. You can see I did not actually use some of the formats that I could have used when I started this to make it a little more legible. That's it. So you now have the start to a powerful data pipeline in about 3 steps, just using the SQL client. An additional note is that the SQL client provides output in real time, but also in read-only. So if you want to store results, like to power a dashboard or report, that's going to require writing to another table. This is super easy. You just use an insert into statement, and then what's submitted, those results will run and store those into the sync table directly instead of loading into the system memory. So that's a really good thing. So now we get to do the next level. So see an actual streaming pipeline, what that would look like. And we're going to use something that's going to be a ton of data at a super high throughput. So all the startup steps will be the same unless you're connecting it with a bunch of other things that don't come out of the box. Those are all in the docs on how to set those up. And then I'm also not adding examples of that because we will be going into Pulsar in a moment. So in this example, we're going to use Datagen, which is similar to Faker. So basically a synthetic data set platform that's highly customizable. And by default, Datagen table will create an unbounded number of rows and a random value for each column for variable size types, char, varchar, blah, blah, blah. The length can be specified. And then additionally, a total number of rows can also be specified, and then you can result in like a bounded table if you want for that. There's also a sequence generator where users can specify a sequence of start and end values. This can be bounded and have when the first sequence completes. So there's a lot of ways you can kind of customize this. So then showing results, this demo is literally, I actually was going to re-record this, and I really like this because it shows just how fast this is on a very old laptop where I forgot I was running a bunch of Docker in the background. So I think this is actually an even better example because it is still just like super fast, which is awesome. So yeah, definitely have data there. So I know I went through that one a little bit fast. I wanted to make sure we had enough time after the AV thing to go through the Pulsar and Flink demo. And so taking a quick step back, why use Flink with Pulsar? So we get this question a lot, and particularly because Flink and Pulsar do share a lot of functionality, but they're actually very complementary, have a very complementary relationship. And a lot of people ask, like, okay, which is better to use in this scenario? Which one's better for that one? And really, pairing them up is just kind of a win-win. So I think that's a pretty cool thing. So specifically, both projects share a common understanding around the idea of unifying batch and stream processing. On the Pulsar side, streams are seen kind of as this like unified view on data. And on the Flink side, batch is seen as sort of a special case for streaming or like a subset of streaming. So what this means is that on the Pulsar side, this relates to where data in Pulsar is abstracted as like infinite segmented streams, and you have those different levels of abstraction, pub/sub messaging layer for streaming, the layer for durable storage and offloading. So a data processing engine could use either level to process the data in the most efficient way. And then where Flink comes in is as a streaming first data processing engine that can also do efficient batch processing. So you'll start to see that you're probably already hearing that there's a lot of compatibility with like, okay, one's kind of starting from here, one's starting from here, and they're kind of meeting in the middle. So taking a step back from that, why is it important to have this unified solution for either of these? Unifying batch and stream processing allows users to reuse code and logic across both batch and streaming, make it easier to integrate different applications and systems, especially if you've been working with a lot of legacy systems. I can tell you from experience, this just makes things so much less painful, which is awesome. So it helps ensure that semantics are consistent. People don't have to learn an entirely new API for each processing mode or each layer of abstraction. And it means that you can really simplify your operations by keeping those configurations and processes the same across systems. It also enables people to mix historical and real-time data, like bootstrapping a job with historic data and then switching to consuming it as a stream once you've caught up, which I think is just like super cool. So then the main differentiating use case for Flink and Pulsar is the part about simplifying the process of building a unified data processing stack. So for example, instead of Lambda architecture with the data stored like in Hadoop to process data in batch, we can just combine these two and get a single stack for storage and processing of both real-time and historic data. So with that, what we've been waiting for, I think you all have the context for this demo. So for this, we're going to use Pulsar's built-in Twitter firehose. For anyone not familiar, the source connector for this receives tweets from Twitter, from Twitter Firehose, and then writes the tweets to a Pulsar topic. So this example that my old coworker Marta Pace put together, we're going to check for Twitter topics related to gardening. So that is step 1. I like to think of this as step 1B, because again, I'm a stickler for checking to make sure that you actually are doing the things, make sure you see the gigantic squirrel, make sure you do the hello world. So I think this is actually kind of an important step, is making sure that do a quick check to see if you have data. So checking, definitely see data. All right, so we're good on that one. Next, we get our big squirrel. We check the Flink SQL client and use a Pulsar catalog to access the topic directly as a table in Flink. And this will make some things a little bit easier afterwards, which you'll see in a moment. And again, I will have links to all these at the end too. This is where the demos start getting a little bit faster and a little bit harder to follow along with as you go. So again, I will be linking to all these at the end if this is going a little fast. So, but there's a workaround that I like to include in here. So Firehose events mostly have a null created time, which is a bummer. But again, very quick way to resolve this. So you can get relevant timestamps and using Pulsar metadata to get the publish time, i.e. ingestion time. I actually really like this workaround because I think it really highlights a lot of what Pulsar can do and how they can be really compatible. So the cool thing about having integration with the Pulsar catalog is now being able to create a table with the exact same schema as the original topic by just using create table like. So in the DDL, you see that we're using the Pulsar connector, tapping into our tweets topic, and then we're just using a JSON format to deserialize the events. So same as before, I just submit the statement using SQL client, and you're good to go. And because we're using publish time and defining that as a watermark, you now have notion of time in your application. So pretty straightforward, so I just kind of count that as step 3. And then to close that loop, you can create a sync table backed by a new topic in Pulsar and insert into it using a simple like windowed aggregation. So you can see the query is pretty much something you could just run on a regular database. So just like standard SQL, doing some aggregation on the total number of tweets over windows of 10 seconds. And then once we submit this query, it'll run continuously and then continuously sync those results into Pulsar. So the final step is you will get a count of the number of tweets for that category in that 10-second window. And that's based on event time. So boom, so that's all done. Super fast workaround, really leveraging a lot of the power of Pulsar in there, which is really cool. So again, I know I went through that last part a little bit quickly. So I want to make sure that you have all the resources you need to keep going with this. So unfortunately, I didn't have time to make a full demo from it, but Yannis Polisos from Stream Native has this just awesome example that you can download and try it out at home. It's very straightforward, and it's a really good introduction to using Flink SQL and Pulsar together. And it has some really good queries just to get you really feeling what it feels like to use SQL for streaming. Because I think that's really important is I want to emphasize that it'll feel like SQL, which is great, but because you're actually accessing stream processing and you're, as I had in that diagram earlier, you're having those continuous queries. I really appreciated what he wrote here because you really get that feel of like what it's like to see the impact of a continuous query running in SQL. The second one is another one that goes, this is actually more in depth into Pulsar and regular Flink, and it's super nice and detailed. So if you want something a little more, just has a little bit more to it, it goes through the full setup, handling multiple streams. One of my favorite things is checkpointing. And it also has one of the things that I see people struggle with the most, which is side outputs and buffering. So it goes through all of that, which is awesome. So I definitely recommend checking out that one. I also really like the diagrams and the README, so shout out for that. And then additionally, one of the Flink founders created a demo for Flink SQL that includes progressively more and more complex tasks and also showcases what Flink SQL can do with different storage systems, different ways of joining dynamic data, and different ways of creating tables with DDL and things like that. So all of these, I think, will give you a really great feel for that entire ecosystem. There's also Flink SQL Cookbook, which has demos and examples also kind of going from like simplest to most complex. I actually really like that it has these little videos too, so you can actually see what it looks like and see that it actually looks the same on your machine. which I always appreciate. And then there's going to be a bunch of QR codes coming up. So if this is something you're interested in, this would be the point if you want to get your phones out. So if you want to get involved, this is the link to our community resources. This is going to have pretty much the entire list of things that will help you either if you want to get help or you want to contribute to the community. And so we also have a super active GitHub. So check this out. This is my check it out, because checking out a commit. Yeah, I did warn you I liked puns. We're also very committed to our GitHub repos. So sorry, not sorry for that one. But yeah, so if you do want to join our GitHub, we have a link here. And this QR code actually has a list of links. So this has our most popular repos, including stateful functions and our actual Flink website, as well as our Jira issue tracker too. And it's kind of a cool way to get to see what's actually happening in the community too. So then aside from our Epic mailing lists and GitHub repos, we also have a brand new Flink Slack space. This one I think is really exciting. I'm really hoping to see more Pulsar people in there because I want to keep seeing what's going to happen there and keep seeing those conversations going between the two. I think it'd be really neat. As I said, it's brand new. We got over 800 users in less than 2 months. And most of the Flink committers and PMCs are in there as well. So just when you join, just don't forget to introduce yourself in introductions. One of my favorite channels there is Show and Tell. So this is a great place to find out about upcoming events and things like that. Which brings us to meetups. If you want to hang out in person or virtual, we have kind of all the above. We're also always looking for speakers. So this is a great way to get involved in that way and keep getting that Pulsar Flink going. I think I'm getting the hook here. Yeah? Oh, sweet. All right. Well, then I'll talk real slow. And I'll throw things fairly. But yeah, so if you want to get connected over Twitter, blog, YouTube, YouTube's a really great way to kind of see all the things that are going on like this. And one note is that, so I've got my Twitter account at the bottom there too. Feel free to reach out with me to me with questions. I have had back-to-back conferences, so I'm a little bit backlogged there, but I promise I will eventually get back to you there. Otherwise, reaching out to the general Apache Flink one works really great too. And with that, thank you all so much. It is awesome to get to see you all in person finally. And huge thank you to all of the event staff. Everyone here has been amazing. And to our amazing MCs, very stylish MCs, extremely stylish. Look at this. I mean, this is amazing. Yeah, so thanks again. And if anyone has any questions, feel free to let me know. And also feel free to come find me afterwards too.